So in the end you will maybe come up with a picture like this. So we have about 60 ground control points added to the scene, and I've checked every location in the end. So the points are marked now in yellow color, and I've added the reference pixel number to each scene. So as you can see, there are some combinations quite good fitting, like combination number 6, but there are also classes that I cannot see in the Landsat picture, so I've chosen another class. In the end, you will just click on report, accuracy report, and you will see something like, or a table just like this. So there were about 3 pixels classified as urban. From this, just only 1 pixel was classified by me as a user for urban, and 2 other pixels were classified for dense urban and suburban. So this is some kind of report. So we have about in grasslands, so I've chosen 12 pixels as grass, but from these 12 pixels only 10 were classified as grass and 2 were classified as suburban, as well as this was performing something different in forest. So I've chosen 18 pixels as forest pixels, therefore 10 were marked normally as suburban area, 7 as forest, and 1 as grassland. And we can go on with that, but in the end you will it's more interesting to see this kind of tables for producers accuracy and users accuracy. And as you can see, there are big differences between them. So just look maybe in the first example here, the urbanized area. We have about 3 reference points in urbanized area. 2 were classified as them as well, and 1 is classified correct. So what does it mean? First of all, check for the urban points. So we have 1 urban here, which is classified as urban, 1 is classified as dense urban, and 1 is classified as suburban. So therefore the producer's accuracy is only 1/3, but given the number of classified pixels as urban, the user was performing by 50% right. So just look for the classified data. Urban, there's 1, there's 0, there's 0, and there's 1 again in the reference points of suburban. So the user was finding one pixel in 2 reference pixels as urban classified. So the user was performing by 50% right. It's a little bit difficult to read this table in the point of this kind of overview table, which is given here in the output, but therefore I can recommend, and I will show you that in the end, some kind of article or some kind of how-to article I found in the net. And but just one more remark on that. So we have chosen about 60 reference points to evaluate this scene, and as you can see, there are some classes I haven't found any pixel. Look here in the dense urban area. So normally you should be able to see some kind of pixel which is part of a dense urban area, but just keep in mind the total area of dense urbanized areas here in the scene is about 5% or something like that. So to get a point choosing the random point generator in a dense urbanized area is quite hard, and in the end, so maybe you have to choose your sample locations to get a point in a dense urban area, and then to see whether it's really dense urban or whether it's not. And the same is resulting here in the value of, let's have a look here in the fields type number 1. I think there's as well just a few number of pixels belonging to that class, and also in the real world there's only a few number belonging to that class. So in the end you have to check for the overall classification accuracy, which is about 63% here in this scene, and this is not that good, but it's highly depending on the number of reference points.